So more polynomial stuff. There's actually there are two new assignments today. First one is really simple. It's just it has to do with kind of classifying polynomials. Piece of cake. There's really no math involved, just kind of vocabulary stuff. So we said last week we talked about monomials, about the definition of a monomial. We looked at properties of exponents. I did tell you though that a polynomial is really just a bunch of monomials all combined, added together. And that's really all it is. A polynomial is the sum of many different monomials. So the requirements for a polynomial really kind of just end up being the requirements for each monomial in the polynomial. What did we say had to be true of the coefficients of each monomial? What kind of number does that have to be? Coefficients have to be what? They don't have to be positive. They could be negative. What? No, they could be different. They could be very different.
Just like numbers and variables.
Yeah, but I want to know what type of numbers do the coefficients all have to be? Not whole numbers. Real numbers. Yeah. So it's not very restrictive. They could be virtually anything. The only thing they can't be is an imaginary number. It can't have any i's involved, right? But any real number is okay for a coefficient, right? The numbers that are in front of the variables. Now, what about the powers that come after the coefficient? What about the exponents? What kind of numbers do those have to be? Whole numbers. Yeah. So either positive integers or zero. And zero is a little bit weird as an exponent, but you'll see why here in a little bit. Okay, when we talk about polynomials, probably the most important thing to know about a polynomial is what is the biggest power of the variable. And that determines what's called the degree of the polynomial. As we're going to see in the coming days, the degree of a polynomial determines the end behavior of the polynomial. Now, we're not really going to talk about that today, but that's coming soon. So that's really important. Highest exponent is called the degree. Standard form of a polynomial, when we want to write a polynomial in its simplified form, its most simplified form, that's called standard form. And all we do is we're just going to write the individual monomials, which are just the terms in the polynomial. We're just going to write those in decreasing power of the exponents. Let's go ahead and click and close. I want everybody kind of focused up here, please. Okay, so then what about number 10? Now, one or more of those terms may not be in the right order. Okay, so let's write this in its standard form. It's kind of messy right now. Say it again. That one? Yeah. Okay, so what about number 10 then? What term needs to come first? Negative k to the fifth. So that one's already in the right spot. Which one would need to come second? Yeah, there's my next biggest exponent. What's next? Okay, then I've got a k squared term. And then what, the 8k? Everybody agree? And then last would be the minus 1. Okay. Well, why is that one last? How come that has the lowest power of k? What is the power of k in that term? Zero. Yeah. Now, we don't write it because there's no need to, but there is an invisible k to the 0 there. How come? What is any base to the 0 power is always equal to 1? There you go. So that's why it doesn't show up. We're just multiplying by 1, right? Okay. All right. So the number 12 is a little bit weird. Now, this is a strange polynomial. We're not going to work a lot with polynomials that have multiple input variables. That's just not, I mean, that's more of a topic for future years. However, we want to know at least how to talk about them. So if we were going to write this in standard form, what do you think we do with these terms that have both x's and y's? How do we know what the degree of that term is, about what's the power of the variable that would go with like this one right here? That one's obviously 2. That's easy. And that one's 4, right? What would that one be, you think?
Well, since they're kind of connected.
They are. They're multiplied.
Since it's like 5x y squared, couldn't it be seen as 5x with a 1 right there? So
It
would
could.
be counted as a 3.
Yeah, it is. It's counted as a 3. Because when you have a product of multiple different variables in a monomial, then you just add up the exponents to see what the cumulative exponent is for that term. So that one would be a 3. So then which terms would we have to put out front?
Like at the beginning.
Yeah.
Wouldn't it be the 9x cubed y?
Yeah, there's one. And what's the other one?
The 5x. Oh, no, it's the negative y.
Yeah, look, those both are tied, aren't they? They both have the exponents in both of those terms sum to 4, right? So they're tied for first place. We got to break the tie. Which one do you think goes first? And this is just total guess. I mean, the convention it's a weird convention, but what do you think?
Is it the 9x one? Because, I mean, it has like a number in front of it. It's positive as well.
Okay, it is that one, but not because it has a coefficient. It's that one because when you have a tie between the exponential weight of two terms, then you always, here's how you break the tie. You look, if I write all the different variables out in alphabetical order, whichever term has the largest power of the earliest variable, x comes before y, right? So this one has an x cubed and that one only has an x to the 0, right? So therefore, the one with the bigger power of the earlier variable goes in first. So we would write this as 9x cubed y minus y to the 4th. What's next?
The 5x y.
Okay, good. So plus 5x y squared. Keep going. Minus x squared. Plus 2, I guess. Okay, makes sense? Okay. All right, so now the game we're playing is we have to determine whether each of these is a polynomial. We'll just vote with our thumbs on this one. So in all 4 of these cases, you're just trying to look for one or more terms in a polynomial that don't seem to fit the definition of a polynomial. Some wonky terms that would make it a non-polynomial. What about that first one? What do you think? Is that a polynomial or not? Thumbs up or down? Everybody vote on this. Give me a little. Okay, I'm seeing lots of thumbs down. I'm seeing a couple thumbs up. Deegan, how come you're right? Thumbs down is the correct answer. How come? Which one of those terms seems like it doesn't work? The 2/5 one. Yeah, that's it. You're right. That one doesn't work. Okay, what's wrong with that term? That doesn't look like a normal monomial, right? A monomial is supposed to be a real number coefficient. Well, 2/5 is okay, right? But then it's supposed to be followed by a whole number power of x. Well, that's not a whole number power of x. That's something completely different, right? Polynomials we never included any square roots in polynomials, with the variables at least, right? We could have what about that last term? Is that one okay? It is okay, right? Because that's a coefficient, right? That one's good. It's a coefficient. It's the coefficient of x to the 0. It's really the constant, isn't it? That just has to be a real number. Well, that's a real number. The 5th root of 7 is just going to be some weird decimal, right? That one's okay. But this is the term that doesn't fit. If I were to write that square root as an exponent, does anybody know what the exponent would be? Square root of x is equal to x to what power? The 1/2, yeah. And that's another way we could see that one doesn't work, because 1/2 is not a whole number, right? Okay, that makes sense? Give me thumbs on that one. Does that make sense? Okay, that doesn't look right. And this one is, as a consequence, that one is a no. Okay, what about the next one? Thumbs up or down? Okay, Atticus, you're right. It is thumbs up. It doesn't look right, though. We need to write this thing in simplified standard form. So what term would go first here? Yeah, negative. Okay, it's the x cubed term. But what could I do to make it simpler? Divide by 5, right? I could divide each of these terms by 5, couldn't I? So I would end up with what? Negative 15 over 5 is negative 3 x cubed. What's the next term going to be? Yeah, over 5 though. So what's that going to be? Yeah, plus 4x, and then finally plus 2. There we go. Okay, so that one is a polynomial. There it is. It's in standard form. What about the next one? Thumbs up or down? Seeing some thumbs up? Seeing some thumbs down? You're right, Ryan. How come? What's wrong? Yeah, look, that's not right. That one doesn't work, does it? That doesn't look like a normal monomial. That does not look like a coefficient times x to a whole number exponent. We never said anything about x's in denominators in polynomials, right? If I were to write that as a power or as an exponent, what is 1 over x? That's x to what power? Negative 1. Yeah, that's the same thing as x to the negative 1. Well, negative 1 is not a whole number, right? Negative 1, whole numbers are 0, 1, 2, 3, 4, etc. No negatives, right? So that guy's disqualified. That's no good. And then finally, that one at the bottom, that's pretty obviously something's wrong there. Which term is a little goofy? Yeah, that cosine x. Again, that's not something we don't, we won't really talk about cosines until like maybe we'll do just a little quick unit at the very, very end of the year. Maybe if we have time.
We went over tangents.
Yeah. Yeah, you would have done probably, you guys would have seen that, did a little right triangle trig probably, right? Yeah. That's really the only time you really see, until you get to trig, that's kind of it for trig stuff. But that's a trigonometric function. That's not a normal looking monomial term. That one is a no. Okay, the next, trigonometry is really cool. You guys are going to, that's next year, well, a year from now, you'll be doing trigonometry. Okay, it's the spring semester of your junior year in pre-calculus. It's pre-calc and then it's trig at the end. So, okay, so what about this now? We want to be able to classify polynomials. So we always give polynomials there's two parts to the name of a polynomial. We classify by degree, and then we classify by the number of terms. So the degree is if the biggest power of x is x to the 0, well, then that's a constant polynomial. Okay. If the biggest power of x is 1, it's a linear polynomial. If the degree is 2, it's quadratic polynomial. We talked a lot about quadratics last unit. We didn't call them polynomials at the time, but now we know that they are polynomials. Degree is 3, it's cubic. The polynomial is cubic. If it's 4, it's quartic. You can remember that, 4 quarts in a gallon. And then if the degree is 5, it's quintic. And beyond that, we would just say like a 6th degree polynomial or a 12th degree polynomial or something like that. The number of terms, similarly, we have just a few different common ones that we refer to. If the polynomial has one term, we already know that's a monomial. Mono means one. If the polynomial has 2 terms, well, bi means 2, so that's a binomial. 3 terms is a trinomial, and anything bigger than 3 terms, more terms than 3, we just call a polynomial. Okay. So now let's name these things. How about this first one? I need to know 2 parts. I need a blue part first, and then a red part to the name. What do you think here? Okay, so now what's that one going to be? What's the degree going to be? Linear. There we go. Because the biggest power of x is 1. So it's linear. And what's the second part? Binomial. There you go. Good. Because it's got 2 terms. A linear binomial. Okay. How about the next one, Hallie? What's that going to be?
Cubic. No. Wait. Give me a second. I'm thinking. Quintic?
Quintic. Okay.
Trinomial.
Trinomial. There it is. Quintic trinomial. Good. Okay. How about the next one? Number 15. Freddie, what do you think about the number 15? That's kind of a weird one.
It's constant.
Constant. Monomial. That's it. Constant monomial. Okay. Number 16. Gideon, what do you think?
It's a cubic polynomial.
Cubic polynomial. I like it. Okay. How about number 17? Matthew, what do you think?
Quadratic. No. 16.
17. Quadratic trinomial. Okay, good. Let's see, Gabriel, how about number 18? What's that going to be? What's the degree? Biggest power of x is what? 4. Okay, so what's that make the quartic? Okay, good, quartic. And what do you think? Monomial. That's it. Good. Quartic monomial. Okay. Let's go back a little bit and try a weird one. Let's try this guy right here. If we were going to name number 12, what would that be? What do you think? Logan, take a stab at that. What do you think? Good. Quartic polynomial. That's it. Yeah. How come quartic? Because the leading term, the term that came first, the exponents add to 4, right? So that makes it quartic. And it's got 4 or more terms, so we just call it a polynomial. Good? Right? Okay. How about, let's see, I just want an example of a cubic binomial. Okay, what do you think? Just make one up. What's a cubic binomial?
6x to the third minus 16.
Okay. 24, yeah, 24x cubed. I like that. So that's right, it's cubic because the first it's a degree is 3, but it's supposed to be a binomial, so I need something else. Plus 3x. That we said plus 3x? Yeah, that works. Everybody agree? That good? Okay, Sophia, how about a linear monomial? Yeah, that's it, 2x. Yep. Okay, good. Makes sense? Okay, so that's the first assignment, the one that is, I'll tell you what the name is. It is, yeah. Come on. Okay, the one that is called 5.1 Practice 2 Polynomials. That's on the stuff we just talked about. It'll probably take you 5 to 8 minutes to do. Okay, I want to keep going though. I want to get through just a little bit more. Today, nothing we do today is really going to be very difficult. I'm going to save like the more challenging stuff. We'll spend time on that coming days. But today we're just getting through lots of kind of easy / review stuff. So now we're going to look at simple arithmetic with polynomials. So just adding, subtracting, and multiplying. None of those are hard to do at all. You really already know how to do it. I just want to show you a couple little tricks for doing it more efficiently. Dividing polynomials is a little tricky. We're going to save that one for another day, not for today. So if we're adding or subtracting polynomials, really all you're doing is combining like terms. If I'm adding polynomials, I literally am simply combining like terms. What if I'm going to do a problem like, we'll do a subtraction example, like number 4. What do you think? In addition to adding like terms, because I'm subtracting polynomials, Naomi, what do I have to do before I combine like terms here? Okay, good. I have to distribute the negative and then combine like terms. Agreed? Okay, so if we do that, if we distribute the negative, what are we going to get? Well, I can get rid of the parentheses on the first polynomial because nothing is being distributed. So I get y plus 4y squared minus 3. Now when I distribute that negative, I get minus 1 minus 2y squared plus 5y plus y cubed. Okay, so if I want to write that thing in standard form, what comes first? Neela, what's going to come first there? The y cubed? Yeah, the y cubed comes first. Good. So y cubed is first. We'll cross that one off. What's going to be next then? There we go. Okay, which is what? 2y squared. Okay, good. So plus 2y squared, and we can knock those guys out. And then everybody, what's the next one going to be? 6y from those two. And then finally, what's my last term? Yeah, there it is. Okay, so that's my answer. Piece of cake, right? There's nothing to it. Adding and subtracting polynomials could not be simpler, right? What about multiplying polynomials? Well, multiplying polynomials is just about as easy. We're going to distribute and then combine like terms and then write our answer in standard form. So, one example is enough for us to go through. We really don't need to do more than that. Let's look at number 6. But I want to look at it, I want to do it 2 times. You'll see why. So first I distribute, right? So what if now, first question is this. I've got 2 polynomials there. The one on the left has 2 terms. The one on the right has 3 terms. I really have 2 options here. I could distribute the terms from the left polynomial to the right polynomial, or I could distribute the terms from the right polynomial back to the left polynomial. Which one seems just a little bit easier? What do you think, Gideon? Left or right? How come? Well, okay, but there's just what's another just a kind of a pragmatic reason, not even really mathematical. What do you think? Yeah, I only have to distribute twice instead of 3 times, right? So in general, it's just a little bit easier if we distribute from the polynomial with fewer terms over the polynomial with more terms. So we'll go this way. We're going to distribute this direction in this case. Well, if I distribute the w, what do I get? W cubed plus w. Okay, good. And if I distribute, I'll do that. If I distribute the negative 7, then what's that going to give me?
Negative 7w squared minus 14w minus 7.
Okay, minus 14w minus 7. And we could play the same game we did before, right? We could just cross these things off as we go, okay? Does anybody see maybe a better way to organize that, though? And this would work for both addition or subtraction or multiplication. What would be a better way to arrange the terms that we're going to be combining? It doesn't seem like a big deal here because I only have 6 terms. It's not that big a deal. But what if we had, let's say we had a 4th degree polynomial times a 5th degree polynomial. That's going to give us 20 terms to combine together. That's a lot of terms. If I wrote those out in a row and crossed them all off, there's a pretty good chance I'd miss one, right? What do you mean by that? W cubes? Yeah. What if we use like a table? If we line them up by columns? Okay, now the first thing you have to ask yourself, when I'm multiplying out this polynomial, what is going to be the degree of my answer? It's going to be cubic. How do you know? Okay, when I multiply the biggest exponents together, I'm going to get a w cubed, right? So I know the biggest power of W is going to be W cubed. And then I just have to create a column for each power as I walk down from W cubed down to the constant. Now, a mistake that people sometimes make when they do this is like, what if, for example, we were missing that 2W term? So let me just do this for a second. What if we were, so we can see that, what if we had something like that term were gone and I distributed? Then I would have gotten W cubed plus W. Okay, a lot of times people just write those, that when they start making their columns, they would make a W cubed column and then skip to a W column. What's wrong with that? There might be a W squared term eventually, right? When I do all my distribution. In fact, there would be, wouldn't there? When I distribute the -7, I'm going to get a W squared term there. So make sure you always leave a place, leave a column for every power of the variable, okay? Because probably eventually you're going to have a term that fits in that column. So when we add these things up, then all we would do is really simple. We would just, when we were starting this, when we were doing our distribution, we would have realized, okay, W cubed is going to be my first column. Then what's the next term? Which column does that go in? Well, that's going to be in the W squared column. The next term goes in the W column. And now when I distribute my -7s, the -7W squared goes in the W squared column. Look how easy. The -14W goes in the W column, and then the -7 goes in the constant column. And now when I combine these things vertically, look how organized and simple that is. I get W cubed -5 W squared. Keep going. Minus 13W minus 7, right? There's my answer. How about that? Okay, see the advantage? Okay, that's it for today. You guys have got 2 assignments. Jump into them.